talk is going to be about 35 minutes, and then we'll have 10 minutes for questions, and then we're going to have a lunch break. Enjoy. The floor is yours.
Thank you. Hi, everyone. Nice to see you for a room, indeed. So I think this talk kind of comes nicely after the first one we just had, because I'm going to talk about bias and how to kind of think about it, how I think about it, and what we can do about it. So let's see how this works. I'm hoping it will work at some point. No? Ah, yes. Okay, I have to point at that thing. All right, so I'm part of the University of Amsterdam. I'm what we call in the Netherlands an endowed professor, which means that I am working part-time at the university, not as my main job. And during the time at the university, I'm part of the Civic AI Lab, which is a lab that's been put together through public funding from the University of Amsterdam, the Free University of Amsterdam, but also the City of Amsterdam. So we're essentially focused on trying to develop AI that's inclusive, and that really is going to try and tackle the societal issues that we have around it. I invite you to check our website to see all the projects that we're working on, but we're essentially interested in mobility, inequality, healthcare, and those kind of topics. So when we talk about bias in AI, we often also hear people talk about fairness. So we want our algorithms that we're going to use in different domains in society to also be fair. So what does it mean to be fair? So I'm going to talk about that in a bit. But first, I want to kind of talk about the motivation. I've heard some questions earlier, and I think that most of you are already worried about some of the harmful outcomes that can come from the use of AI systems. So I don't think you're the type of crowd that I have to convince that, harm or, biased AI algorithms are bad. But sometimes I kind of have to do that convincing. But you probably heard some of these controversial stories. We call them war stories sometimes around AI, about some algorithms that are used, for example, in recruiting with Amazon. There was an issue with their tool that was discriminating against women. You probably have heard the toeslag affair in the Netherlands, where the tax office has used some algorithm that has been discriminating against folks from ethnic minorities. There's a lot that has gone on also during the pandemic, where people started using algorithms because there weren't enough people to do the tasks. And I can go on for a while about this. But essentially, when we do deploy AI systems in society, in government, to perform some of these tasks that are usually done by people, we do end up having issues. And so, because we have issues, we also have compliance, and we have regulatory we have rules in place that tell us that we have to be compliant with certain regulations to try and avoid these type of stories. And you're all familiar with GDPR, I hope. And one thing that is very interesting in it is that it was the first time that we had some official law in Europe that will tell us something about the right to the subject, to the individuals, to not be kind of judged, not to be associated with an outcome that's solely based on an automated system. So people would also have a right to contest the decision that's been made by the system, but they also should be informed. So regulation is another reason why we should be caring about fairness. And of course, GDPR fines are a real thing. So in the past few years, they've been given to companies that have not been very careful with the private data, personal data. But we could also have it that in the next few months to years, that companies would have fines if they have algorithms that they develop that are going to discriminate against people. So what is bias? Now is the time for some definitions. So when I use bias in this talk, it will be to refer to systematic errors that are going to create unfair outcomes. And these errors can come from algorithmic design, from biased data collection, or some poor decisions that were made in putting a model together. And algorithms are going to learn this bias and perpetuate it. So why do we care so much about algorithmic bias? This is a question that I get a lot, and it's essentially, algorithms are cheap, they are very easy to put together, and they are much cheaper nowadays to scale and to really use at a level where they're going to harm or affect millions of people. So now we really have to kind of pay more attention compared to a situation where we'll only be using software that would just with a lot of human intervention. So when we talk about bias, we have to talk about fairness. So fairness is essentially caring about how the outcomes of a model are going to be attributed to particular groups of people. If you've heard stories about AI applications that went wrong, it's always along the lines of constructs of gender, for instance, or ethnicity. So this is what we're talking about when we talk about groups of people. And the core principle of wanting to do fair AI is that we have to avoid bias. We have to avoid these errors that happen, even if they're going to perpetuate something we're already doing in society, whether we recognize the discrimination or not. I'm going to give some examples. And essentially, you have to think of fairness in AI as a political construct. So if it's not illegal, someone has to decide that it's not okay to do something. It's not ethical, or it's just something that maybe the law has yet to catch up to, but we shouldn't be maybe automating a task or using an algorithm for a particular task because the potential for harm is too big. But this means that a group of people, usually business leaders, government leaders, will have to decide whether they care about fairness or not. So when we talk about fairness, we talk about avoiding bias, and bias is linked to this notion of harm. I invite you, if you're interested in this topic, to look at this paper or this actual conference that's been given by Kate Crawford, who is a pretty prominent researcher in fair and ethical AI. And they talk in this presentation about different types of harm. So we have harm of allocation, harm of representation, and harm and reduced quality of service. So essentially, when an AI goes wrong, we end up in one of these three situations. So the first one is harms of allocation, and this is when the system allocates or withholds certain groups from an opportunity or resource. This is what happened with the tax office in the Netherlands, if you're familiar with that story. We essentially told people that they didn't have the right to a welfare allocation because of the system output. Harm of representation is essentially when you're going to train something, a model, on data that doesn't have a very complete representation of the target population. For example, when we talk in terms of doing a Google search and then you search in a job, for example, CEO, and a few years back when you did that, you only had male CEOs as a result. Right now, Google has found a way to kind of correct for that, so you can type any type of job that are always going to be men and women represented. Reduced quality of service is something that people tend to think is a bit more superficial, but I think it's equally important. It's essentially when a system is going to produce a degraded experience for the customer. It could be a camera that is operating with an AI system that cannot detect your face because your skin tone is different from what it's used to, what it was trained on. It could also be, for example, having random checks at the airport systematically go off every time you have a darker skin going through a porting, or maybe a lighter skin. I'm just giving some anecdotal examples. And so these harms do exist. We know that they can happen, and the idea of my talk is to try and give you some tools to try and think about them. So why do these things happen? They happen because we have an algorithmic pipeline, right? So we're going to start with a target population. In this case, I'm really thinking about situations where we use an AI system on personal human data. It can happen so when you're going to target the population and decide what type of data you're going to collect. It can also happen when you choose the features that you're going to use from the very large database that you have. It can happen when you're going to put together some assumptions for your model. And of course, once you've kind of put all this together, you end up having a discriminatory outcome. So what are the different types of bias that we have? So this is essentially to explain why does this happen? Why do we see these issues in the data? So again, another reference to a very nice, complete, very comprehensive paper that talks about all the different types of biases and why they do occur. But I'm only going to talk about 3 types and illustrate them. So the first one is historical bias, and it's essentially reflecting the way we are kind of put together as a society. When we talk about gender issues in terms of algorithms that are going to do things like recruitment or selecting candidates, you often have issues when it comes to gender, and I'm going to illustrate that in a bit. Representation bias, that's what I just mentioned about the Google and the CEO. So essentially you have data where you don't have all the groups of folks that you would like to be inclusive or include in your data. They're just not represented. So you can't learn. Your model cannot learn if the data does not represent that. And you have measurement bias, which is essentially when you screw up, right? You want to measure something, you end up measuring something else because you have some correlation between your variables, or you just didn't do it on purpose and ended up having a harmful outcome. So I'm going to illustrate these 3 types of bias. So historical bias, I'm showing this because it links to this Amazon story from a few years back, where they had this tool that was supposed to automate candidate selection. So you can imagine that a company like Amazon receives a lot of CVs from a lot of people that want to work there. And what they ended up doing is having kind of a more harsh selection process against women. And women that were equally competent as men would actually not be ranked in the same way. And one of the reasons that people put forward to explain that is that the kind of the way the tech industry is formed is kind of prone to bias, right? You have a majority of men, and this means that when you're going to have any type of data set that you're going to collect on this type of activity, on recruitment or selecting candidates, you are by definition or by design going to discriminate against women. You're just not going to have enough representation. And this kind of perpetuates the bias that there is against women in tech jobs that's been going on for years, and I hope you all know about. And essentially, your model is just going to capture that. So this is what we call historical bias. Representation bias is something a bit maybe more visual for you. This is also a very nice example that I invite you to look up. So a group of scientists essentially tested different image recognition software, and they wanted to see when these software would actually fail. And what they saw is that they tend to fail when they have to deal with darker-skinned female profiles, female pictures. And that can essentially be explained by the fact that they have less of these profiles or less of these type of individuals represented in their data set. Measurement bias. So this is a story that happened in the UK during the pandemic in 2020. I'm not sure if you've heard about this, but it had to do with high school final exams, and that the kids couldn't sit on the exams. And so essentially the government said, we're going to use an algorithm to kind of predict or guess the marks that the folks would have had if they could sit on their exam. What they ended up doing is essentially discriminate against students that were living in poorer areas and in public schools. Because some of the features that they've used in their model, that was supposed to be fair, were kind of linked to class size, location. So what they ended up doing is for students that were living in these poorer areas or were less advantaged than kids that would go to private school, they would have kind of grades that were lower than what would their own teachers expect. I'm not sure if you remember this, there were a lot of kids on the streets and kind of really claiming for this to be scrapped, and they actually did manage to get that done. So this is a typical example of measurement bias, right? We didn't want to discriminate against the students, but we ended up doing it. Okay, now, how can we avoid this stuff? Again, regulation and ethics, they give very good frameworks to kind of, when you're in a data science team, you then have very clear rules of what you can and cannot do. So GDPR is crystal clear in what can you do and cannot do in terms of profiling, in terms of data selection, given the right of your customers, consumers to opt out from a particular program. And the ethical committees, I'm referring to the one from the EU because a lot of folks refer to that in the AI community. They also have very interesting ideas about how we can prevent harm. So this is just one way. I'm happy to talk about it further offline, but to me, as a practitioner, as a data scientist, working in a team with people, it's not something that's super concrete for me to follow when I have the dilemmas or complex questions. The FACT AI community, so we call it FACT. FACT stands for Fair, Accountable, Confidential, and Transparent. There are a lot of workshops, a lot of affiliated conferences, so if this is a topic that interests you, most of the material here is open source, and you can actually access it for free online, so you can also re-watch tutorials, etc. This is a very nice place to start if you're interested in this topic. And then, since I'm a practitioner, since I'm a data scientist, I try to look at it very practically, and I look at it from a perspective of, okay, I have daily stand-ups with my team. I need to figure out a way for them to think about what it can happen and what problems they can encounter in terms of bias. And essentially, in the pipeline, this happens when you're starting testing your model. So there are a few things that we can do. We can check data sets and balances. So this is typically relevant when you have different groups of people you have in your data. So again, we have data on personal information, and assuming we're working for a retailer and we're looking at how to recommend some promotions for customers. So let's assume we have gender or location or something that we will call a sensitive attribute. And I would check whether the favorable outcomes of my model, so when I'm going to give something good for my customer, like for promotion, am I doing it in the same way when it comes to someone who lives in Rotterdam or someone who lives in Maastricht, right? We could try and do those kind of things. So the notion of fairness in this retail example might be not very exciting, but the idea is you should treat people that have similar, relevant features in the same way. Right, you shouldn't start giving, let's say, more favorable outcomes to one group compared to another just because of their gender. And usually you don't encode that on purpose in your model, but it can just happen out of correlation with other variables. It's very essential, and I try to do that in my teams, for folks to understand the model behavior. It's not always possible because essentially the way data science teams are built is that you put something together, you put a model together, you push it to deployment, and then it kind of comes out of your hands. And you're very lucky if you're able to also kind of monitor the way your model behaves, but you're involved in the pipeline. But if you do have that luck, and if you're actually able to monitor what's going on once your model is in the wild, that's the best way to see if it's actually behaving the way you intended or if there are potential problems. Another way our AI community is trying to tackle these issues of bias and discrimination is through mitigation algorithms. And you've probably heard of that if you're interested in this topic. So mitigation means reducing severity, seriousness, or painfulness of something. And I'm putting this definition because I just want to make sure we all agree on what mitigation algorithms are. And the literature in these past few years has really focused on trying to develop tools that will come on top of your model that you've already built to try and kind of make it more fair, right? So, yeah. There has been a lot going on in this space, and it's been often presented as the solution to all of our issues in terms of bias. And I think you can already maybe tell that I don't agree with that type of way of thinking. But I do give this some kind of guidance about how these have been used. So AI Fairness 360 is something that's been put together by IBM. I think it's a pretty solid platform where they essentially take all the packages, the open source packages that have been developed by academics and folks in industry that have to do with mitigation, so how to kind of try and fix bias, and put it in one platform. So it's super handy. They have an API. You can also, if you're not a programmer, you can also just go on their website and do some kind of try and mitigate bias on your own data set if that's what you want to do. So some of the requirements for using these type of tools is that you have to know what the sensitive attribute is. So earlier in the examples that I gave, I talked about gender, skin color, those kind of things. And this is what we call sensitive attributes because they're essentially personal information that you shouldn't have to use, really, when you develop any model. Well, I'm generalizing a bit, but gender is typically a protected attribute, right? You shouldn't decide whether to do something based on gender unless you're actually personalizing your model. I'm talking about let's say, use case where gender shouldn't be relevant. But you should have access to that data. And for a lot of data scientists, we are kind of a bit frustrated because people talk about these sensitive attributes as if we have access to them. But through GDPR, we have to have a very, very solid case to be able to use them in our day-to-day work. You have to also have a defined fairness objective. So you essentially have your model, you know what the potential harm can be, and you're essentially on a quest to fix it. That's an extremely rare combination of conditions in my experience. Like, you don't actually know what the problem will be before you deploy your model and have it operate in the wild. Another requirement to kind of follow this type of solution is to be able to have a fairness intervention. So you should have enough agency and you should have enough power, I would say, in the process to say, hey, there is a problem here, we're going to stop, or we're going to mitigate. Again, as a data scientist, this is extremely difficult to kind of, to do in practice, because you're in a data science team, you report to some, business leader, and business leader wants results, he wants KPIs to look nice and shiny. So when you start talking about fairness interventions, it gets really complicated, because often business goals are not aligned with these fairness constructs that, as I mentioned earlier, unless you're doing something illegal, they're really more in the realm of political kind of stand. And also, another requirement for really doing this right when it comes to mitigation is to be able to monitor your fairness intervention. So once you've decided to change something in your model to kind of make it more fair, you should be able to watch how it's actually going to work in order for it to, in order for you to check whether your intervention worked. So essentially, this is what I've said now, so I'm going to skip this slide. In practice, there are a lot of limitations when it comes to testing and correcting for fairness and for bias in general. So we do need to have often inaccessible sensitive features available. The potential fairness intervention cannot be monitored. It costs money, or it's just simply technically not possible. And I just mentioned the compatibility between your goals as data scientists who want to do the right thing and your business leaders who just sometimes just want results. So essentially, when you want to operate in this space and really care about these topics of fairness, you really have to accept that it's going to be a lot of uncertainty, and it's just going to be a very complex, landscape. So I'm going to give you an example of how this works in real life. This is something that's similar to a case that I had to deal with in my job. So assuming that we have an organization, we call it X, that decided to acquire what we call a succession planning tool. So in large organizations that have thousands of people working for them, they do what we call succession planning, meaning that at the end of the year, based on your performance, they're going to give you some score that's going to tell you whether you will be considered for the next job, next interesting job that's going to open up in the company. So for each of these kind of key jobs that are maybe at the director level and higher up, you'll have some potential candidates that can actually apply to them, and you will be considered for the job based on that. So this company decided to automate this tedious task. I put here I think it was from HBR, an article item that essentially encourages companies to use algorithms to be more fair. And this is something that I've heard from a lot of business leaders. We need to use AI because we need to put the human out of the equation and we need to be more fair. That's kind of an actual argument people use. And so in this case, the model that this software tool that's been bought uses is a regressor that's trained on historical data to predict when the candidate has a positive recommendation score. If you have a positive recommendation score, the next time there's a top job that's opened up in your company, then you'll be considered for it, so you'll be able to interview for it. So we're going to think about this as a tool that generates a score, and it's going to be trained on, or it has been trained on HR-related metrics, so performance, education, tenure. And the practitioners, so essentially folks like me, maybe folks like you, their task is to evaluate the tool and improve the use of it from the HR team. So typically when you're in a data science team, you're often being asked to do this kind of work because you're supposed to be the expert who understands everything about bias and fairness. And even if this is a very intricate, complex problem, we often look at the, let's say, more technical folks to try and solve these issues. So who I call a practitioner in this case is anybody who's going to have to evaluate that tool. I do that a lot for many companies. They come to me and they say, we bought this software, we thought it was a good idea. We want to make sure that if we use it, we're not going to get into trouble. So how do we do that? This is the type of people that I call practitioners. So folks that are not going to be able to, adopt any mitigation algorithm, but folks that have actual constraints in where they can apply the influence. So if you think of this pipeline that I've showed earlier in a different format, typically when you're a data scientist, you have this pipeline, and there are some places where you can intervene and some places where it's harder for you to have impact. So typically the business case is not going to come from you. It's going to come from the business or from your product owner or someone who's going to decide what the company should be working on. The data selection itself is something you typically can have a say in, but you also have kind of access to the data that's available. And then the development cycle is typically where the data science comes in. And then you have the testing, the deployment, and the monitoring. And I highlighted these in red, if you can see that. And I highlighted them in red because they're the most critical part, and they're usually the part where you have the least influence as a data scientist in the company. Because there are considerations of regulatory constraints. So if I'm going to test my model to see if this succession planning tool is going to discriminate, I need to have access to information about gender, for example, and about the performance scores. So am I really able to do that? Am I really able to get that data from HR? In my experience, at least in the Netherlands, it's incredibly hard to do that. Deployment and maintenance costs. So you have to consider that, right? If you're going to want to do some testing on this tool, you probably will have to do that in collaboration with the vendor. The vendor is going to charge you extra to do that. So this situation is something that happens a lot, and it's not straightforward. And the feedback loop is important because what you want is, once you've okayed the use of this tool, what you want to see happen is be able to see if the decisions that were made sense to the HR department or not. But often putting that together, putting that in place, is also kind of time-consuming, and again, not something that is straightforward to do. So I think I'm probably coming across as quite negative about how we do mitigation in in an industry context, but I also want you to be aware that how hard this is. But there are some solutions out there that I've been trying out, and I think for the most part is something that you don't necessarily expect. But I'm going to come to that in a minute. So the first thing you should do if you find yourself in a situation where being asked about fairness, or explainability, because we've talked about that earlier in the first talk, how transparent is the system and how can you help me figure out whether I should be using it, is ask questions. Ask a lot of questions. Even if you don't know, you're not supposed to know the answers to these questions, but it actually challenges the people who are giving you this task to kind of think back about why they've made those decisions to begin with. So what are the potential harms that could occur in this case? I could typically think about that myself, but what I would prefer to do in this situation is to talk to the HR folks and tell them, okay, what's the worst case scenario? What would happen if you don't use this tool? What happens if you use this tool? What is a fair outcome? What is ideal? Like, what would be a perfect thing that we want to see happen if we're going to use this tool in our company? And then similarly, what is an unfair outcome? Can we ensure fair outcomes? So I would ask this question without the tool first. Like, how do you as an HR department make sure that, the folks that are going to allow to interview for these jobs are being treated fairly? And who is responsible for ensuring fairness, right? Is it you, HR department? Is it ethics and compliance department? Is it the data science team? Is it the vendor? Who is responsible for that? Surprisingly, this question triggers the most conversation in my experience because people are like, oh, actually, someone has to be responsible for this stuff. And again, I wrote more stuff about responsibilities, but I'm going to skip this now. So one thing that really, really helped me in doing this type of exercise in a lot of companies is, as I said, ask a lot of questions. And what I've been doing with them is these fairness challenges that I call them fairness challenges. So I don't call them audits because an audit is a word that is very scary, but I prefer calling them a challenge. So it's just essentially sitting down with people that have made a decision to buy this tool and just ask them lots of questions. And this exercise typically can be done in less than 2 hours. And what I do is, we're going to ask questions about different topics. First, privacy. And then can we also talk about governance? So who is in charge of this tool? Like, if the tool goes offline, if it has something wrong, is it the IT department that takes care of it? And actually asking all these questions, you realize that we don't have the answers to all of them, which is a problem. And then you actually then have room and opportunity for improvement and to educate people to kind of think ahead of time when they want to automate these type of tasks. And actually this kind of sends you back to the process itself of succession planning, right? And what I had in this kind of semi-fictitious case is that the folks from HR would start kind of talking about the tool, and they started talking about, why are we doing succession planning the way we're doing it? Is it fair? Should we kind of have an external agency come in and do that for us? So triggering this conversation also helps people understand that AI is just a tool, and it's not going to kind of be separate from the decisions or their knowledge that they have about, the candidates in the company or the processes in the company. Some people create AI. AI doesn't create itself. And often these business leaders, that they are exposed to a lot of information about hype and AI, and AI is going to save us all, etc. Like, an AI is just something a bunch of people like me and you have created, right? So we have made assumptions, we have selected data, and we probably made mistakes in doing so. The second thing I do a lot is educate people. And this is not necessarily something you would want to do when you're a young, graduate. You probably want to build really cool stuff and see it kind of have its own life. But education is incredibly important because it gives you a lot of freedom in doing the things that you want to do. So education can be quite boring for folks that are very busy in companies. It could also be boring to educate folks about, very basic topics. So you kind of want to challenge them to do something more complicated. So there are creative ways of doing education. And I wanted to mention this website that essentially creates comic books about AI concepts. So you have stuff about transparency, about explainability. And this is a very cool one where it talks about like muffins that go wrong in the oven. And it's essentially kind of an analogy to AI that goes wrong. So you have all the ingredients, you did everything right, you put it in the oven, you probably put it, too hot or not hot enough, and then something goes off. So I really encourage you to kind of look at these comics because, well, they're fun. But it's also kind of a different way of talking about AI. I don't know about you, but I'm a bit saturated. Like, it's a bit getting always the same thing when it comes to AI. People talking about robots and Teslas and those kind of things. But I think it's nice to kind of go back to the basics a bit and just trying to explain to folks what is AI exactly. So this is essentially my story, is to encourage you to think critically about all these mitigation algorithms, what they can and cannot bring. And I will be happy to share these slides later on, but I try to kind of put a list of things that you should look into if you're interested in reading more about this topic. I'd like to end with this quote from this very nice book that is freely available online. It's called the Fair book. And essentially, this is about kind of remembering that any machine learning system is trying to make some change in the world. You have to consider it in the context in which it's being deployed, right? In which it's being used. So this socio-technical system is essentially not just data and a model, it's also human beings and human behavior interacting with each other. And you really have to keep that in mind when you think about these problems, because often, especially around these times where people talk a lot about AI can bring to humanity, we just forget that it's just, again, an interaction of some math, some coding, and some data sets, and people making decisions in between. Well, that's it for me. I'm happy to take questions. Thanks for listening.